This is a tutorial on the dot product of two vectors. When we talk about the dot product, we're always talking about vectors. The dot product and the cross product are two different ways of multiplying vectors, and they give you different answers. This tutorial is only going to focus on the dot product. When we take the dot product of two vectors, all we do is take their x values and we multiply them together. Then we take their y values and we multiply them together. Then we take those two products and we add them together. So when you take the dot product of two vectors, you end up with a scalar. Remember, vectors have a magnitude and a direction. A scalar is just a number. It's just a magnitude. There's no direction to it. So let's try taking the dot product of these two vectors. Here we have vector n, and it's equal to 3i hat minus 4j hat. And vector m is equal to negative 3i hat plus 5j hat. Now these i's and j's, they just indicate what direction our vector is moving. Here, vector n is moving 3 in the x direction. That's what this I hat means. N is also moving negative 4 in the y direction. That's what this j hat means. So if we're going to find the dot product of n and m, we take the x values, or the numbers in front of the I, so 3 and negative 3, and we multiply them together. Then we take the y values, or the numbers in front of the j's, negative 4 and 5, and we multiply them together. Then we add these two products. 3 times negative 3 is negative 9. We're going to add that to negative 4 times 5, so negative 20, and this is equal to negative 29. So the dot product of vector n dotted with vector m is equal to negative 29. Again, we started with two vectors and we ended up with a scalar. Now the dot product is kind of like multiplication of vectors. The dot product also follows the commutative property. If I dot n with vector m, well, I'll end up with the same number as if I dot m with n, so the order doesn't really matter. It also follows the distributive property. If I want to dot r with the addition of m and n, then that's the same as dotting r with the vector m, and then dotting r with the vector n, and then adding those two together. So the dot product follows the commutative property of multiplication and the distributive property of multiplication. Now the dot product is useful because it can help us find the angle between vectors. And we have a formula for this. The cosine of the angle between our vectors, that's equal to the dot product of our two vectors divided by their magnitudes multiplied together. So let's say I had vector A, which has the components 4i and 9j. That means vector A moves 4 in the x direction and 9 in the y direction. So from here to here. This is vector A. Now I also plot vector B from the same point. Vector B moves 7 in the x and negative 2 in the y. So if we start at the same place, down 2 and over 7, take us to about there. So this would be vector B. If we wanted the angle between these vectors, call it theta, well then the cosine of that angle is equal to the dot product of these two vectors divided by their magnitudes. So first let's find the dot product of these two vectors. if I want to find the dot product of A and B, that's equal to their x values multiplied together. So 4 times 7, and we add that to their y values multiplied together. So 9 and negative 2. 4 times 7 is 28. 9 times negative 2 is a negative 18. So our dot product is equal to 10. Now I need to find the magnitudes of these two vectors. The magnitude of A, that's equal to the square root of its x movement squared plus its y movement squared. So the magnitude of A, that's equal to the square root of 97, which is approximately 9.85. Now let's find the magnitude of B. The magnitude of B is equal to the square root of B's movement in the x direction, so 7 squared, plus its movement in the y direction, so negative 2 squared. That means the magnitude of B is equal to the square root of 53, or you can think of that as approximately 7.28. So I have everything I need. I have my dot product and my two magnitudes. I'm going to plug them into this formula, which means the cosine of our angle theta, that's equal to the dot product, so 10, over the magnitudes multiplied together. So the square root of 97 times the square root of 53. If you plug all this into a calculator, you'll find that the cosine of theta is approximately 0.13947. Take the inverse cosine of each side, and you'll find that theta is approximately 82 degrees. So the angle between vector A and vector B, this angle right here, would be 82 degrees. So if we can use the dot product to find the angle between two vectors, let's try using the dot product to determine if two vectors are perpendicular, because that would mean the angle between them is 90 degrees. So we're going to use our formula. The cosine of the angle between our two vectors is equal to the dot product of our two vectors, so A dotted with B, and then divided by the magnitude of A times the magnitude of B. So first, let's find the dot product of A and B. Well, we have a 3 in the x, and then B has a 5 in the x, and we're adding that to A's y value, which is also 5, times B's y value, which is a negative 3. So A dotted with B is equal to 15 plus a negative 15, or it's equal to 0. Now let's find the magnitude of A. That's equal to the square root of the amount A moves in the x, so 3 squared, plus the amount A moves in the y squared. So the magnitude of A is equal to the square root of 34, which is approximately 5.83. Now the magnitude of B, that's equal to the square root of its x movement, so 5 squared, and its y movement, so negative 3 squared, Again, we're going to end up with the magnitude of b is equal to the square root of 34, which is approximately 5.83. Plug all this stuff in. We have our dot product and our two magnitudes. So the cosine of theta is equal to 0 over the square root of 34 times the square root of 34. Well, let's look at something here. It doesn't matter what the denominator of this fraction is, because our numerator is 0. So it doesn't matter what we're dividing 0 by, it's always going to be equal to 0. So if we say the cosine of theta is equal to 0, and you took the inverse cosine of both sides, you would find out that theta is equal to 90 degrees, which would mean that these two vectors are perpendicular. The key thing to realize here is if you ever take the dot product of two vectors, and that dot product ends up equaling 0, that means that these vectors are perpendicular. You don't have to do any more math. Again, as soon as you do the dot product and you realize the dot product comes out to 0, your two vectors are perpendicular. Now let's try using the dot product to determine if two vectors are parallel. Here I have vector A, which is 4i minus 5j, and vector B, which is 8i minus 10j. Once again, I'm going to use my formula. The cosine of theta is equal to the dot product of our two vectors, so A dotted with B all over the magnitude of A times the magnitude of vector B. First, let's find our dot product. A dotted with B is equal to their x values, so 4 and 8 multiplied together. And then we add that to the y values multiplied together. So negative 5 times negative 10. 4 times 8 is 32. Negative 5 times negative 10 is a positive 50. So our dot product is equal to 82. Now let's find our magnitudes. The magnitude of vector A is equal to the square root of its x movement squared, so 4 squared, plus its y movement, which is negative 5, and that's also squared. That means the magnitude of vector A is equal to the square root of 41. And if you're curious, that's approximately 6.40. Now let's find the magnitude of vector B. That's equal to the square root of its x movement, which is 8, squared, plus its y movement, which is negative 10 squared. That means the magnitude of vector B, that's equal to the square root of 164, which is approximately 12.81. Plug all this into our formula here. That means the cosine of theta is equal to our dot product, which is 82, divided by our two magnitudes multiplied together, so the square root of 41 and the square root of 164. Plug all of this into your calculator, and you'll find out that the cosine of theta is equal to 1. Take the inverse cosine of both sides, and you're going to find that theta is equal to 0. Well, if the angle between these two vectors is 0, then they must be laying on top of each other. So if the dot product is ever equal to the two magnitudes multiplied together, then your two vectors are parallel. Or if you calculate the angle between, and that angle comes out to be 0, you can also say that your two vectors are parallel. So now let's try using the dot product to do some problem solving. Here we're told that a boat, which can travel at 10 miles per hour, crosses a river. The current of the river pulls the boat downstream at a rate of 3 miles per hour. So what direction must the boat travel in order to reach the opposite side directly across from the launching point? So if we have a river, and we have our launching point, and we have our destination point, which is directly across from the river. This is the direction we want to travel. Now the current of this river travels downstream at 3 miles per hour. So what I want to do is I want to drive my boat at some angle against the current. So when the current pulls me at 3 miles per hour, I end up directly across the river. So if my boat travels at 10 miles per hour, which is this black vector, then I want some of this 10 miles per hour to fight the 3 mile an hour current. So if we say that we're going to move in the x direction, or the negative x direction, 3, and then we're going to move some mile an hour in the y direction to get directly across. The idea is to find this angle. Well, you notice that I turn this into a right triangle, which means my vector here, this 10, or the boat vector, we'll call it b, vector b, that's equal to negative 3I plus xj. And the magnitude of vector b, well, that's 10 miles an hour. Now when you find the magnitude, you take the square root of the x direction, which is a negative 3 squared, plus the y direction, which would be x squared. And we know the magnitude is equal to 10. Square both sides, I'll get x squared plus 9 is equal to 100. X squared is equal to 91. And x is equal to the square root of 91, which is about 9.54. So our boat then is traveling in the y direction at 9.54 miles per hour. So now I want to find this angle theta. If I want the angle between these two vectors, this green one and this black one, I would need to find the dot product. Well, we found the component form of our black vector, of our 10 mile an hour vector. That's negative 3I plus the square root of 91j. Our green vector, the speed the boat travels directly across our river, is just the square root of 91j, or 9.54j, because it's moving strictly in the y direction. So the dot product would be the negative 3, which is our movement in the x. Our other vector here has no movement in the x, so times 0, plus the black one, some movement in the y, which is the square root of 91, times our green vector, y movement, which is also the square root of 91. Negative 3 times 0 is 0, and the square root of 91 times the square root of 91 is just 91. That means the cosine of the angle between these two vectors is equal to the dot product of these two vectors, which is just 91, divided by the magnitude of these two vectors. Well, the magnitude of our green vector, since it only moves in one direction, is the square root of 91. The magnitude of our black vector, well, we know that. We started with that. It's 10. Plug all of this into your calculator and you'll get the cosine of theta is approximately 0.9539, and that theta is about 17.5 degrees. So that means if your boat travels at 10 miles an hour and the river travels at 3 miles per hour, and you wanted to end up directly across the river, you should pilot your boat 17.5 degrees upstream so the river will take you back and you'll end up directly across the river. Now the last thing we have to talk about when we talk about the dot product is turning a vector into two perpendicular vectors. Now we already do this a lot actually. If we have a vector, we have been turning this into two perpendicular vectors. One that goes in the x direction and one that goes in the y. This vector here moves 4 in the x and 7 in the y. And we would write it 4i hat plus 7j hat. This vector doesn't actually move 4 to the right and then up 7. But over its entire length, it does this. And it actually moves in this diagonal. So what we've done is we've taken this vector and we've turned it into two different vectors that are perpendicular. But what if we wanted to turn it into perpendicular vectors that weren't in the x and y direction? If I had vector A here in blue and I wanted to turn it into vector B and a direction perpendicular to vector B, then I would turn vector A into a vector that looks something like this, and then another vector that looks something like this. These two vectors are perpendicular. Notice they don't move in the x or y direction, but together they add to get our original vector. Another way to think of this is how much of vector A is moving in the direction of vector B, and how much of vector A is moving in a perpendicular direction to direction B. Instead of knowing how much of our vector is moving in the x and y direction, we've picked two different directions and we want to know how much that vector moves in those two different directions. So let's look at this example. Here we have a block on an inclined plane. This block has a weight of 20 pounds. And we want to turn this force of 20 pounds, which is a vector pointing straight down, into a vector that's perpendicular to this plane that the block is sliding on, and a vector that's parallel to this plane that it's sliding on. I want to know how much of this 20-pound force is pulling this block down this plane. And then how much of this 20-pound force is pulling this block against the plane. Well, to do this, there's a formula I can use. Let's call this direction down the plane V. So this is the direction vector V. I'm going to call my weight vector, vector W. And I want to turn this W into two vectors that are perpendicular. So I want to find out how much of this W vector will make vector A and how much of it will make vector B, which is going in my V direction. Now there's a formula that we can use to do this. We can say that vector B, which is this vector that's moving in our direction vector, This is equal to our weight vector, so W, dotted with our direction vector, so V. And then this is divided by the magnitude of our direction vector squared and then multiplied again by that direction vector. The amount of W that's in B, or that makes up this vector B, is equal to the dot product of W times V, our direction, divided by the length of our direction, so we're kind of creating a unit vector here, and then multiplied by that V. So let's work this out, and hopefully it'll become a little bit clearer. First we need our vectors W and V. Well, vector W does not move in the x direction. It only moves in the negative y direction. So it's got a 0i, and then it's downward in the y direction, so minus 20j. Our direction vector, V, I can get that from the sides of my triangle. We have a 3 and an 8. So V is moving 8 in the x and then down 3 in the y. So I need to find the dot product of vector W and vector V. Well, we take our x values and we multiply them together. So 0 times 8. And we add that to our y values multiplied together. So negative 20 times negative 3. 0 times 8, well, anything times 0 is 0. Add that to negative 20 times negative 3. The dot product then is equal to 60. Now I need to find the magnitude of my direction vector, vector V. That's equal to the square root of the amount V moves in the x squared, so 8 squared, plus the amount V moves in the y, so negative 3, and that's also squared. So the magnitude of direction vector V is equal to the square root of 73, or approximately 8.54. So now let's plug all this in. B, which is the vector or the amount of our vector W that moves in the V direction or down the incline, that's equal to the dot product, which is 60, divided by the magnitude of our direction vector V, which is the square root of 73, and we're squaring that. And then we're also multiplying this by our vector V, which is equal to 8i minus 3j. Now 60 divided by the square root of 73 squared. This is the same as 60 over 73, and then multiplied by 8i minus 3j. Here we're multiplying a scalar by a vector. So you just take the 8 and you multiply it by 60 over 73. And you take this negative 3 and you multiply it by 60 over 73. If you do that, you're going to find vector B is equal to about 6.58 in the I, and then minus 2.47 in the J. So this is our vector B. Now we just got to find our vector A. Now notice if you take A and you add it to B, you'll end up with your original vector W. So instead, to find vector A, we're going to take our vector W and we're going to subtract or add the negative of vector B. Well, vector W is equal to 0i minus 20j. If we add the negative of B, which is just the opposite direction of the same angle, we're adding a negative 6.58i plus a positive 2.47j. I just multiplied my x and my y components by negative 1. Now you would add the x's and add the y's. So you'd end up with negative 6.58i and then minus 17.53j. So these are the two vectors. One is in the direction down the plane, and the other one is in the direction into this plane. And these two vectors make up the total vector W, or our 20-pound weight. So that's how you can turn a vector into two perpendicular vectors, which are not the standard x and y perpendicular vectors. And now that we've done that, we've completed the tutorial on the dot product of two vectors.